Test, test. Okay, let's see if this is working. Test, test. Okay, let's see if this is working. Test, test. Okay, let's see if this is working. Test. Okay, looks like this is working then. Let's see. Hmm. God, where is it? Oh yeah, that was hard to find for a moment. I should probably move that somewhere else. Hmm. Let's see how many people are here. 7 people. Okay. So, can everybody hear me fine? Okay, that's good. Just to confirm, is everybody here coming from a programming background? If anyone hasn't come from a programming background, type in the Twitch chat. Okay. We're gonna try to make this short, so hopefully I can get through everything as quickly as possible. Okay. So the Unreal Engine 4 workflow is actually pretty simple. You just have to know where everything is because it's not really intuitive where everything is in the beginning. Oh, we got someone who doesn't know about programming. Okay. So just to explain, programming is just moving data around different locations and then having them interact with each other in a way that produces behavior that's um, in order to produce the behavior that you want. Basically, you have to interact the different components using specific sets of logic and get them to basically work. The way you do that is to use loops and variables to create code, basically. Uh, okay, so I'm probably not going to explain about how programming works this time because this is going to be a short tutorial about how the workflow goes. So I'm sorry if I couldn't cover how programming works. We'll try to cover that next time if you're interested. But this time we're mainly going to be focused on just how to program in Unreal Engine 4. Okay, so first of all, for anyone who's programmed before, you know that you have variables, your floats, your enums, your booleans, your integers, um, as well as combining those variables together. So when you combine those variables together and they don't have any functions within them, we all know it's called a struct or structure. So the way you create a structure in Unreal Engine 4 is you actually have to go in this main menu HUD. It doesn't matter where in the HUD you go to. Anywhere is fine, but we'll just stay in the I guess the library folder since that's where some of the other ones are. So we go to blueprints, enumeration, and structure. These are the two ones that you normally would program with all your other codes like variables, integers, and such. But over here in Unreal Engine 4, you have to specifically make them inside the UI and place them here. So the thing with everything in Unreal is everything can be made a class. So you can say, let's see, where is the button? Okay, so anything like over here, I'm hovering over lake water. I can just edit this blueprint. And then you immediately see that this is the entire code for the blueprint. So everything is like this, and then you can see if there's any variables over here. You can see ocean material, water scale, wave speed, blah blah blah. These are all the variables that are needed. You have a linear color, that's a spectral struct I'm not that familiar with, but you basically got everything. So no matter what it is, as long as you can see it in the editor, you can always click on it and then just edit blueprint. And you can see whatever variables it holds and whatever logic is used to perform the behavior that you expect it to. And wow, this one's large. Okay, so now getting into the logic. So how do we do basic programming here? Once we know where the structs are and the enums, we're not going to go over how to use them in this tutorial, but you can pretty much just go, for example, here and then add a new variable, and you can turn the type as a structure. You could pull it out. Let's see. Let's search for stats component. Like we already know that's one of the things that we have. So, okay, all of a sudden we have another stats component inside our character stats component. Although this is completely unnecessary, so we'll delete it. But that's how you access your structs. The ones you create at least, because the previous ones, as you saw, the pre-made ones are already here, so you can automatically access them. But if you make anything yourself, if it's an enum or a struct, you have to first create it in the UI editor, and then you'll see them appear here. Okay, so the nodal programming. Let's just go back to the stats example that we kind of did in the previous tutorial, but it was done really slowly, so I bet a bunch of you left before we even finished it, and it was pretty really slow. Okay, so let's see, where is it? Okay, since some of you said that your eyes were burning, I turned into the darkened mode so that there's no more issue. Let's see. So we got the so many channels. Let's see, where is it? Okay, right here. The finalized game stats. Okay, so we haven't implemented knock up, charge, knock back, all those knock effects yet, but we've already implemented HP, MP, and damage. So we're gonna look at those functions right now. So you've seen how we create variables. Just add any variable, choose the type of variable that you want, name your variable. Like, let's see, how about tree, for example. Whoops. You just drag it over here, and then you get a getter and a setter. These functions should be fairly familiar with you guys who've programmed before. So the get function is obviously just to access the value itself, and the set function is to set the value to something that you want. Maybe you calculate this through some mathematical formula or something like that. Note that there's a huge difference between getters and setters is that this node is just like a small thin line, while this one is much thicker and it has these white nodes to the sides. Now these you can be considered as the main execution nodes. This is the actual flow of the program. So what that means is, like, if you have an event, for example, let's use the event on begin play. Okay, event. Let's see. Actually, no, keyboard. Let's see, where can I access an event? Okay, oh, this one's outside, so I can't do that. Okay, so let's start over here, and then we use an event of on begin play, like right here. So what happens is that as soon as the play button is pressed, this event gets fired. Okay, and then anything that's attached to this gets executed next. And in this case, it's calculate base stats. Now let's look at what this is. Let's see. Okay. Let's move these to the side. So as you can see, the thing that I just did was expand node, and this shows you all the functionality that was inside that node, and it picks it out. This is also used really easily to move things into a function. So once you've decided all your logic and everything you want, you can just highlight everything and just right click. Whoops. Make sure you don't have that in there. Okay, so you have to right click one of the nodes. You can't just right click anywhere. Right click one of the nodes and collapse the function. And then everything just becomes one single function. Okay, we're going to just undo that, and then we'll show everything here. So as you can see, we don't actually have every single node connected in an execution line. So unlike when you normally program, where you have to say line by line, for example, initialize vitality, or no, you have to write vitality equals, in fact, no, you have to write you have to write vitality equals vitality times class vitality scaling, for example. Um, in this case, the thing that you want to calculate is going to be the next thing that you're going to connect with your execution line, or execution flow. And this is how you go through every variable that you want to calculate. Of course, these nodes, they're content they're context sensitive. So for example, if I were to redo this calculation over here, I would take let's see, which one is it? Effective values, effective vitality. So take it out, set effective vitality, and this is a float. And I know this calculation is a float times float. So I could search float, and as you can see, it already gives us a lot of float and float because it knows that the node that's coming out of it is a float. So if I write another float, that means it has to be another calculation with another float. And that way you can get that node out really quickly. Let's say we initially started with, instead of a variable with a 3.5 scaling or 2.5 scaling we have here, we just use 2.5 in the beginning. And then vitality, we could just take the getter. So look at our stats, we just look at vitality, get vitality, and we just connect that node. Now, we can do stuff like this, and it's really convenient in blueprints if we have a bunch of constants that we can later change, because we can just right click this, promote to variable, and all of a sudden, bam, it's a new variable that we can use. Okay, so that's the basic workflow of calculating new variables and getting the calculations. In this case, we're just using mainly only float calculations because I really did not want to worry about some truncating a float into an integer and then losing some value in it. Okay, so as you can see with all these stats, we calculate a lot. We calculate vitality and health, so max health and initialized health, spirit, intelligence, magic attack, magic armor, mana, strength, physical attack, physical armor, and maximum inventory weight. If you look at all of this, there's some stuff that we haven't calculated yet. And that's mainly these resistance values. The reason why we haven't calculated those resistance values, I can just show you right here. So this is the calculate resistance function. And then once again, we'll just expand this node. So the main concern about the calculate resistance function is this thing right here, this 70 in all three slots. If we undo that for a moment, we'll see that it takes a target self, so it always has access to itself. Every function does. You can see this function also has a target self, but also has this input called attacker level. If we look at the calculation for getting the resistances, it's based on, let's see, right here. It's the amount of physical damage reduction and magical damage reduction equals the physical armor / magic armor divided by physical armor / magic armor plus attacker level times 150. So it needs the attacker level. And that's why it's a little bit different, because we can't directly calculate that without an attacker, right? We could put a level 70 in the beginning just to get a value. For example, like for those of you guys who've played DFO, you've seen the stat appear as how much percent resistance you get for an enemy at the same level. That's probably what they do. They just put they take your level and they feed that into this kind of function in here, and that's how they generate the initial resistances. But they calculate the resistances the exact same way. So your resistance obviously changes with different leveled enemies. And then we look at this over here. Oh, wait a second. Okay, so this is the apply damage function. Now we're going to get into how do we take information from other classes. Okay, so this is the interaction component that Jordy made. If you look at the send damage, send buff, send CC, they look really simple. You just take a damage instance. Damage is a struct basically, And if you use every struct and every class, you can always pull that node out and then put a break instance. A break instance just lets you access every single variable component of that. And so in this case, you have the send damage, you have the source, you have the target, and you have the damage. So the damage is obviously an input because it's shown over here. By the way, the purple is the start node of the function. As you can see, if we open this, purple is also the start of the function. So the color coding is quite important to get used to, as it will save you a lot of time trying to figure out things. Okay. So in this case, you're just taking the target and you're sending that target information and the damage to the send damage function. Now let's look at the apply damage function. Okay, as we stated before, the damage function or the resistance function requires the attacker level. So it makes sense when you create the apply damage function to take the attacker level as an input. But if we look at the calculate damage function, it's quite simple. You just take the attacker's physical attack, the attacker's magical attack, and then you multiply it by 1 minus the percent physical or percent magical damage. You add that together, and that's the total damage that you have. Now, in the character component, let's see, where is it? Okay, so this is the create damage instance that Jordi has made. So the input, as you can see, is a character interact component. So in other words, it has a reference to another class. Wait, am I right, Jordi? It has a reference to another class of the same class as it. Yeah, okay, yeah. Reference to another object of the same class. And also it takes an amount of damage because this is basically kind of like a filler stat at the moment. And this is an instance type, damage instance. If you want to look at this is a, let's see. Oh, it's an enum, so I can't look at that much. But if we want to go back for a moment, we can look at the damage types, I think, right here. Right? So it's an enum that can be any one of these. So it makes sense. It also gets the self, because everything you can have a self, I think. Yeah, get a reference to self. This way, or what I think Jordi was trying to do here is that he wanted to, when he creates damage, he wants to send a instance of the sender as well as the target. So the attacker and the person that's taking the damage. He wants to send both instances. That way we can interact between the two player characters in a sense. Now if we look at the player character itself, we can see how giving that functionality allows us to have some interactions between them. So now once again, we're looking at that damage component. So the on damage, let's go back to here, and let's see. Send damage, on damage, find references. Okay, right here. So every time we do something that sends damage, then this is going to call on damage. And then this on damage, this is called an event dispatcher. You can add one over here, name it whatever you want. And this basically sends an event outside of the object itself. So since this is a component, we can attach the character interaction component to a player character, and then every time we call the event dispatcher on damage, then the player character that owns the character interaction now has access to this event. And this is shown over here. Now it can go to interact component and you right click, add event. Ooh, this is hard to see. Add event, and you can see add on buff, add on CC. I can't add on damage because it's already there, but you can see if it wasn't there, you could have added it. So now you can break this damage instance once again because it is a damage structure. And we take the stats component of the target and we take the physical attack. So I'm just taking the amount of damage and putting that into the attacker's physical attack and then using the apply damage function. The apply damage function is here. You just take the amount, you calculate your resistances because now you know who your attacker is. Then you calculate how much damage that you resisted from that. Then you subtract all that health and you get your return function. Okay, but this is not what's really special about Unreal Engine 4. Like, you could have passed things in here like this if you had a function that gives you this amount. But what's really cool about Unreal Engine 4 is that components can access their owners. So over here, we can not only get the level, we can actually get physical attack and magic attack. So we can go over here, we can go to source, okay, right, get owner. Okay, so get owner means now we're in the player character itself. And then we can just get the other component. Whoops. Wait. Get component. Okay, give me a second. Let's see. Oh, yeah, it is. Okay, so you get component by class. And then you say which class you want. So stats component. Whoops. Delete. So character stats. And then over here you can get level. Get the level here. Then you can get physical attack. Let's just move everything over a little bit so it's easier to see. Whoops. Okay, ignore the multiplier for now because this hasn't been fully calculated yet. But if we had a weapon, for example, you just apply the intelligence-based attack multiplier on top of that. The same thing with the physical-based attack. Yep. So as you can see, what's really special about Unreal Engine is that everything is either a blueprint or a component. And since everything's a blueprint or component, you can, because we already have two stats component, right? But even if we pass in an interact component, we can get the owner and then access the other component. So it's kind of like if you had a class that owned two objects, object one can access the owner, which then can access the other object. So that way you can always pass one, you can turn one of the objects into an interaction object, and then always throw that interaction object. You can always pass that interaction object as a reference, and then you can use that reference to get to the owner and get to any other object within that class. I think that's what you were planning to do with the. That's why you created a interaction component, right, Jordy? The reason why it's not there is because we don't have weapons yet. Our attacks, if you just take a quick look over here, if you call calculate resistances, apply damage, calculate base stats. Yeah. So if you look at the calculate base stats, we calculate the intelligence-based attack multiplier and the, oh, I forgot to change the name of this, but this should be physical strength-based physical attack multiplier. The reason being is if we take a quick look at the damage calculation that we've written down, it's here. It goes base weapon physical damage times 1 plus strength divided by 175. So the reason why we don't have a physical attack or a magical attack, or we shouldn't have a physical attack or a magic attack at the moment, is because we don't have a base magical physical weapon damage yet. I'm not sure if I think we don't want to put that in the stats component. We want to put that in like inventory component or something, or equipped, something like that. Equipment. It should be in the struct. Okay. I'll add that then when I try to do my next commit and such. Okay, so that should be the overall. Oh yeah, if you have OCD, then you can go like this. Like you don't like how this is intersecting this node right here. Just double click it, and then you can go like, wee. Whoops. Ah. You can just move it like this. Same thing with the things here. Just double click, and then you can create a what's it called? A reattach node. Also, you can split this up, for example, if you wanted to do that. Then that makes everything look really nice as well. So that's a really nice shortcut that you can use as well. So as you can see, now that you know how to create your variables, um, create your enums, create your structs, as well as how to interact, how to calculate your values. As you can see, you almost always only use the execution nodes, the execution white lines for setting values and changing values. All of the logic behind calculating those values, or actually no, all of the calculations for those values are also are not used on the white execution line. However, if you have a if function or a loop, these do have white execution. So you have to take note of that once you're thinking of how to design your functions. And then you can also highlight everything, right click one of the nodes, and then collapse into function. That's how you create your functions. Also, if you click on this thing, the purple, for your function, you can add new inputs and outputs. I'll just do that right now. New parameter, and then that'll appear, whatever struct, whatever type you want. And if you have an output, add one over here, it creates a return node. See, before we didn't have anything to return, but now we do. So we can just, oh my god, that was stupid of me. Connect that over here, and then you can return whatever value you want. And then the thing that's most important about this system and everything in it is the fact that you can have sub-objects of a class call the owner and then call any other object within that class. So the flow of information is very streamlined in Unreal Engine 4. I think that's it. If there's any other questions, Jordy and I can try and answer it. No questions? Does everybody understand how to use the blueprint system now? Okay, I'll take that silence as a yes then. Okay, I guess that'll conclude this stream. I tried to make it as short and sweet as possible. So I hope you guys found that useful, and I'll see you guys on the Discord.